Hello everyone, I am Jitin and I am a part of Vidhai. Exams Vidhai is a non-profit initiative by the students of IIITDM Kancheepuram to give free coaching and resources to school students to prepare them for national level exams like NTSE. In this video, I am going to cover the topic of arithmetic progressions, AP. The contents of this video will be definition of an AP, general term of an AP, sum of terms in an AP, properties of AP, and a few examples. Let's start with the definition of an AP. An AP is a sequence whose terms either increase or decrease by a fixed number. This is called the common difference. Let's say A is the first term and D is the common difference. Then in general an AP can be written as A plus D, A plus 2D, so on. If D is positive, then it will be an increasing AP, or else if D is negative, it will be a decreasing AP. You can observe that the nth term or the general term can be written as A plus n minus 1 into D. And if we are given a general term of the AP, then we can get its common difference by doing D is equal to Tn minus 1. Because these are consecutive terms, the difference will give us the common difference of the AP. Now, if we were to write the nth term from the end, then we can write it as L minus n minus 1 times D, where L is the last term. So if it is an increasing AP from the left to right, then we can get the reverse AP by making it decrease from the last term. Or else you can say that it will be a decreasing AP with common difference minus D. Now let's take an example. The first term of an AP is 5 and its common difference is minus 3. Find the 11th term. Here we can use the nth term expression Tn is equal to A plus n minus 1 times D, where A is the first term which is given as 5 and the common difference is given as minus 3. Clearly it is a decreasing AP, so the 11th term should be less than the first term which is 5. Substituting in the formula, we get the answer, the 11th term as minus 25.
Now let's look at the sum of n terms in AP. Sn is equal to n by 2 times a1 plus an. We know that an is equal to a plus n minus 1 into d. Hence Sn is equal to n by 2 times 2a plus n minus 1 into d. Now let's look at an example. Find the sum of n terms of the sequence an, where an is equal to 5 minus 6n. Given an is equal to 5 minus 6n, let's compare it with a plus n minus 1 into d. Now observe the coefficient of n. You can find that d is equal to minus 6. We know that a is nothing but first term, so put n is equal to 1. You will get a is equal to minus 1. Now apply the formula n by 2 times 2a plus n minus 1 into d and substitute the values accordingly. You will get n times 2 plus 3n. Let's go to the next one. If the sum of the third and 11th terms of an AP are 8 and 20 respectively, find the term of first 10 terms. The third term is a plus 2d, which is 8, and 11th term is a plus 10d, which is 10. Now solve for a and d. You will find a is equal to 5 and d is equal to 3 by 2. For the sum of 10 terms, apply the formula Sn, putting n is equal to 10, a is equal to 5, and d is equal to 3 by 2. You will get it as 117.5.
Now let's quickly look at some properties of an AP. The first one, if you add or subtract a fixed number to each term of an AP, then the resulting series is also an AP and its common difference remains the same. Next one, if you multiply or divide an AP with constant number, then the resulting series is also an AP. And if you add or subtract two APs, then term by term, then the series is also an AP. Next, when you are required to take three terms in AP, preferably take it as a minus t, a plus t. And for four terms, take it as a minus 3d, a minus t, a plus t, and a plus 3d. Now let's look at the problem. The digits of a positive integer having 3 digits are in AP and the sum is 15. The number obtained by reversing the digits is 594 less than the original number. Find the number. So it says that we are given a positive integer and it has 3 digits, and they are in AP. So as I told in the previous slide, let's take the digits as a minus t, a and a plus t since they are in AP. Now the sum of the digits would be 3a. That's the actual reason why we have taken to be a minus t, a and a plus t. Given that it's 15, now a would be 5. Now let's use the condition. The original number would be a plus t into 100 because a plus t is a digit in 100th place, plus a into 10 because it's in the 10th place, and a minus t into 1, which will give you 111a plus 99b. When you reverse the digits, a minus t will go into 100th place, and a will remain in 10th place, and a plus t would go to 1st place. It would be 111a minus 99b. Now we are given that the number obtained by reversing is 594 less than original number. So this number minus this number would be 594. On solving, it will give you d is equal to 3, and we have already obtained a is equal to 5. So the number would be a plus t into 100 plus a into 10 plus a minus t into 1, or just use this expression, and you will get it as 852. Let's look at another problem. The angles of a quadrilateral are in AP. The greatest angle is thrice the least angle. Find the greatest angle. So a quadrilateral has 4 angles and they are in AP. So take them as a minus 3d, a minus t, a plus t, and a plus 3d. Now the greatest angle will be a plus 3d and least angle will be a minus 3d if you take d is greater than 0. According to the question, the greatest angle is thrice the least angle. So solve it and you will get a is equal to 60. And we know that sum of all angles in a quadrilateral is 60 degrees. Using that property, sum of angles will be 4a. Again over here d disappears on adding, that's why we have chosen like that. Now 4a is 360 and a is 90. D is a by 6, which is 90 by 615. Hence the greatest angle will be a plus 3d, which is 135 degrees. That's it. We have covered the concepts as well as some problems relevant to this chapter and the exam. Thank you for attending this lecture. Please check the description box for extra questions for your practice as well as lecture notes of this chapter.